I really don't.
All right, guys. Whoop. All right. Adding and subtracting radicals. I promise you there is a method to my madness. Okay? You all may think I'm absolutely crazy, which, yeah, y'all run with that. Okay? But there are things that I do, and there's a reason that we do them. Okay? So we had to cover simplifying radicals first, because in order to add and subtract radicals, they need to be simplified first. So, actually, let me turn on the light here so you can see the whiteboard for a minute. Shield your eyeballs.
We can see it without the light.
Miss Smith needs light. She's old. Okay. All right. So
you can see. Not us.
In order to add or subtract something like this, what did they say we needed? What did they call those?
Like terms.
Like terms. Okay? You needed that x squared and x squared. Okay? In order to add and subtract radicals, you need to have like radicals. So what I mean by that is I need to have something like 3 square roots of 2 plus 4 square roots of 2. These have to match in order for you to add. If they were two different things like 4 square roots of 2 plus 3 square roots of 3, that cannot be done. It's already done for you. Okay? You cannot combine anymore because they don't have the same radical and radicand. So we're trying to get like terms here. So if you would actually go through and solve this, you keep that like term. So we keep the square root of 2, and you add your coefficients just like you would have done here, where this becomes 5x squared. This becomes 3 plus 4. So it ends as 7 square roots of 2.
Wait, so the square roots, they're like the radicals of a variable?
Mm-hmm.
Wait, is that the exact first one?
Okay. So in order for us to do that from here, I need to simplify each radical first. Okay. So that's where this becomes long and difficult. So I need to simplify 18 before I can do anything. So we need to break it down. What is a prime number that divides into 18?
3.
We can do 3. You can do 2. Let's do 3. That leaves me with 6. 3 and 2, 2 and 1. Okay, so 18 is actually 3 times 3 times 2. What am I grouping in for this one?
Twos.
Twos. My index is a 2. Please do not get confused. -3 is a coefficient. In order for it to be an index, it's got to be tiny. Okay, that is a coefficient. So my index here is technically a 2. There is no index written. So I'm grouping in 2s. So I've got a group of 3s. Okay, my 3 comes out front, and I'm left with the square root of 2. Don't forget, though, I already have this -3 that needs to drop down. When I already have something out front, it gets multiplied by whatever else you bring out front. So this actually becomes -9 square roots of 2. Did I lose anybody? Kind of. Close to it. Okay. Let's try the next one and see if we can catch on, okay? So my next one, I need to break down 8. Okay, I need to break down 8. What does 8 break down into? 2 and 4, 2 and 2, 2 and 1. So Mo said this is 3 2s. 1, 2, 3. Okay. Again, what am I grouping in? 2s. So I've got one group of 2's. So that becomes 2 square roots of 2. Are you good there? Okay. The last thing I need to do then, I already had a 3 out front. So it needs to come down and multiply by what I already have. So that becomes 3 times 2, which makes this 6 square roots of 2. And it's positive, so we're adding. See how you just created like terms now? Okay, so when we're finished, those will actually go together because you've simplified it enough for it to work. Okay, the last one I need to try to simplify is 24. 3 and 8. 2 and 4. 2 and 2. And 2 and 1. So this is 2 times 2 times 2 times 3. Okay, what am I grouping in for this one? 2's again. This is still square roots, so we're grouping in 2's. Okay, so I've got one group of 2's. That 2 comes out front. So this becomes 2 square roots 6. You multiply them back together. Okay. So Rebecca says there's a minus sign up there. So this actually becomes minus 2 square roots of 6.
Why would it be 1 though? Isn't 1 supposed to always be in front?
Exactly. So you 1 times 2 is 2.
Negative 1 times 2.
Wow, I'm slow.
2.
Okay. You're absolutely correct. So there is an unwritten 1 here. Just like we did here where we multiplied what we pulled out front by what's up here. Negative 3 times 3 is negative 9. 3 times 2 is 6. Negative 1 times 2 is negative 2.
So we're gonna do this. Oh wow, I'm like really something.
Okay. All right. Once you've simplified everything, we need to combine like terms. Okay, so my only like terms here, it says determine which radicals can be added or subtracted. To be combined, radicals must have the same index and radicand. So it has to be square root and square root. And the number or number and variables underneath of it, which is your radicand, have to be the same. So the only things we can put together are negative 9 square roots of 2 and 6 square roots of 2. Okay, so I can't combine negative 2 square roots of 6 because they don't have the same. They've got the square root, but I have a 6 instead of a 2. So Rebecca says that this goes together and gives me negative 3 square roots of 2. Again, you keep this, and negative 9 plus 6 gives me negative 3. Okay? So my final answer then is what you get when you combine the two. So negative 3 square roots of 2. And then don't forget to bring down what you couldn't combine, minus 2 square roots of 6. The more examples that we do, the better off we are. I think multiplying square roots are a lot easier than adding and subtracting. Dividing might throw you for a little bit of a loop, but I do believe that multiplying is easier than adding and subtracting. To me, adding and subtracting is way too much work. All right. Please glue this in on page 79. Yes, ma'am.
Have you ever met a corgi?
Have I ever what?
Met a corgi, the dog?
Yes.
I met one yesterday. This thing was, it was fully grown. It was so heavy, and it scratched me.
Oh.
No, that's a small radio. He tried to lick me on my face, and his teeth were on my eye, and I really hurted. Hurted. Why do I say hurted?
I don't know.
When I don't think about it. Then what do I say in it, like in a heart? It don't sound right.
I will tell you this though. Hurted is not a word, sorry.
It doesn't sound right saying it hurt though. Because it don't hurt no more. So you gotta say it did hurt, not it hurt.
Listen, how about you just skip the word hurt and say it was painful?
It was painful.
That works too.
Okay. We're gonna make another little booklet.
No.
Yay! Okay, I need you to take this paper and fold it in half hot dog style so your words and problems are on the outside. Make sure you make it crispy. Crispy. You want a crispy fold like bacon. Yes. Yes.
Oh, but you want ice cream in the cup. It wasn't me. It was my cousin. Your cousin is right. You read it.
Exactly. I put my ice cream in the cup.
We tried to go turkey bacon. That just was not working for me.
People that I eat ice cream in the cup.
I eat cereal in the cup.
Exactly.
That's more normal.
I can't eat cereal.
I've never heard of that.
I eat cereal in the cup. First of all, cereal in the cup is a milk cup.
All right, open it back up.
Right. You want to change those things?
Open it back up. We're going to fold it in half, hamburger style.
Right. Well, this is your homework, Miss Lynn.
No. These are the examples we're going to do now. Okay? So, fold it in half this way. Open it back up and fold it in half that way.
Hamburger.
Hamburger. Fold it like a burger.
I thought you said open it up. Wait, I'm confused. Wait on. You lost me. That's so.
You've done two things.
Make the ends crispy. Become white.
Did you need a flashlight to find what you dropped on the floor? Okay? Fold it in half one more time.
I'm lost.
Guys, you have got to stop talking and pay attention. We are wasting time because you're lost folding paper. Okay. Once it's in half, hamburger style, fold it in half one more time. So adding and subtracting radicals are on top. Your title page should always be on top. You should always be able to see it when you're folding. Okay. No, you don't need to fold it down because we got to open it up and cut it here for a second. Okay. Once you fold it so it's nice and skinny like this, don't forget to crisp your edges up. If you need to use your scissors to run it across it, or if you've got long fingernails like me, you can just run your fingernails across it. Okay. You're just going to open it back up once. Find yourself the side that doesn't open. Okay, so it should be facing you this way to make your cut. Adding and subtracting should be on the bottom left-hand side facing you. Okay, take your scissors and just cut to that fold that you just got done making. So you're going to take your scissors and cut to here. Okay. So just cut it to there. Do not cut any further. Okay. Yes, cut to the origin. You made yourself a coordinate plane. Okay. It's creepy. Nom, 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 nom. So when you open it up, you get this fancy little diamond in the middle.
That's not what's going to happen if I put didn't do it. I didn't, Miss
Fold it in and fold your booklet.
That's why I just did
Like that again. Just like this.
Anybody else need help getting the fold? You gotta open it the whole way back up.
Now just hold it like this, right?
How you gonna do somebody else and you?
because I know how to do the engine part. It's that part I don't know how to do.
Yeah.
Open it up. Who else needs me?
Oh, yeah.
Oh, my.
It feels like
Kenzie needs my help.
I have a very shitty little.
Oh, is it supposed to be like this?
Like, it looks like it was made by a 5-year-old. Like, write a book on how your business day went. Shit like that. Yeah, like this. Shut up.
But he's 16. No, he's 16 about tomorrow. I'm
Does anybody else need help with their booklet? Yeah, that looks great. Awesome.
Hey, Miss Smith, while you're helping everybody, can I go use the restroom?
Right. I've never been.
Hurry up.
Anybody else?
Oh, and you got a paper cut? Oh, no. Paper cut in math class. All right, guys. Adding and subtracting radicals. Here we go, my friends. Okay. If you open it up, my first problem's on the left. Woo, I can make that pretty big. So, we need to simplify each one of these. Take a look at my first radical. -3 square root of 2. We don't need to simplify it. The square root of 2 is already in simplest terms. 2 is already prime. So I'm just going to transfer that down. -3 square roots of 2. Let me shrink that just a little bit because you can't see what I'm doing. Okay. That way I've got room to do all the work that I need to do before I start to put everything together. Okay. So I did move pretty far down the page. I still left some room, but I did move pretty far down the page, so it's out of the way. We know it's done. Okay. So we took care of that one. So I'm going to cross it off. Okay, take a look at the next one. 20 is not in simplest terms yet, so I need to make it. So let's take 20. I need a prime number that goes into 20. 5. I heard 5 first. If you did 2 first, that's fine. Bless you. That's fine. You still ended up with the same answer. That's okay. It does not matter which one you actually did first. So this is 2, 2, and 5. What am I grouping in? What's my index? 2's. That's a square root. So this comes out front, and I'm left with the square root of 5. Don't forget to bring down this 3, though. So this actually becomes plus 6 square roots of 5.
So you add those?
You multiply them.
Multiply.
You multiply them. 3 times 2.
Yeah.
Okay. You're fine. Now is the time to ask me questions. So when you go home and you're doing your homework, you're like, oh, I got this.
Homework.
Oh.
He just had homework through the weekend.
Oh.
I hope you don't give homework. No, I'm just saying.
I'm giving you the hugest project over Thanksgiving break.
I just want to
Wait, are you serious?
Go do it.
Jeez. All right. All right. Negative 3 square roots of 8 is 8 prime. No. So let's try to break it down. 8 breaks down into 2 and 4, 2 and 2, 2 and 1. So it's 2 times 2 times 2. What am I grouping in this time? 2's. Okay, so this becomes 2 square roots of 2. Don't forget this negative 3 that's out front, though. So this actually becomes negative 6 square roots of 2. At this point, everything is simplified. What can be added or subtracted together? Good. This and this are like terms. So this becomes negative 9 square roots of 2 plus 6 square roots of 5.
That's it, right?
That's it. It is. It's very tedious, bless you, to make sure everything's in simplest terms first. Now, if you had my special happy calculator, it does this for you. Unfortunately, you're not allowed to use my calculator on your tests. TI-89 is a no-no on the North Carolina state test.
Why? Because you'll get all the answers instantly.
It does a lot more than a TI-83 does. Like, you remember how I taught you how to factor with the box method? If you would have typed in factor x squared plus 3x plus 4,
I need that.
it would have done it for you. It would have
Well,
told
why
you.
can't we have
X
that?
plus- Too smart.
Are they trying to make us fail? Like,
No, they're trying to make you think.
In the workforce, if we need to do something, we're gonna have that calculator.
No, you're not.
So why not give it to us now?
Well, have our phones. Like they say, you won't always have a calculator with you every day, but you always got your phone.
Exactly.
Unless it dies.
She's small.
Oh, I always
All right. So let's take a look at this one. We've already factored 20 on the previous problem, so I'm not going to waste my time. I'm just going to pull the factors over that we just did in the last problem. So in the last problem, we said 20 broke down into 2 times 2 times 5. Okay, we just did it on the last one. On the left. Okay, I was just trying to save us some time here. So we group in 2's. So that becomes 2 times the square root of 5. And don't forget to bring down that negative 2. So negative 4 square roots of 5. Okay. 18. Is it prime? No. We got to do something with that. You said 3 and 9. That should be 6. You're doing 2. 3 and 6. If you did 2, you could do 9. So 3 and 6, 3 and 2, 2 and 1. So this becomes 3 times 3 times 2. We've got a group of 3's. Good, Jeremiah. The 3 comes out front. Square roots of 2. And again, don't forget to pull down that 2. So 6 square root of 2. Yes.
So you know how your index, you're supposed to group by your index, right?
Mm-hmm.
Well, what if, like, why did you group 3 if your index was in 3?
I didn't group in 3's. I grouped in 2's.
Oh.
I grouped 3's. There's 2 3's.
Oh, so if
It doesn't matter what the number is, it's how many you circle go by the index. Okay? Good question. Okay? Take a look at the last one. -2 square roots of 5 is 5 prime. Yes, so that one just comes on down. We don't have to do anything. -2 square roots of 5. Okay? So everything's simplified now. Once it's simplified, we need to add or subtract. So what goes together?
-4 square root of 5, -2 square root of 5.
What does that become?
-6
-6 square roots of 5, and then bring down +6 square roots of 2. That's your answer. Please understand, I could have also written this as 6 square roots of 2 minus 6 square roots of 5. It's the same answer. It's just reversed. That's okay. The order doesn't matter. Okay.
You should make the rest of this. That's not good for
All right. Take a look at this one. Woo! This one looks pretty.
Are 2 of them already prime?
2 of them are already prime. This one is already prime, so we've got -3 square roots of 5. This one's already prime, negative square root of 5. So we took care of those ones. What'd you say about the square root of 6? 6 becomes what? 2 times 3.
And then it equals 6 again.
Okay. You can't group anything with the square root of 6. Square root of 6 is already in simplest terms.
So you just keep
Okay, so you just keep it. So minus the square root of 6. You can't do anything with it. Good call, Justin. Good call. Okay. So now what goes together?
-3 square root of 5, -1 square root of 5.
And what does that become?
-4 square root of 5.
Fantastic. Genius. All right. So you'll start to notice stuff like the square root of 6 can't be broken down. Okay. You'll get ones that technically 6 is not prime, but you cannot reduce the square root of 6. So if we bump over to the next one.
Would that one stay -2 square root of 6?
Absolutely. Okay. So we know that 2 square roots of 5 are already prime. So I'm going to bring that down. 2 square roots of 5. And we just figured out that the square root of 6 can't reduce. So we can also bring that down. 2 square roots of 6. You are absolutely correct. Okay. So 45 can be broken down. What goes into 45 that's prime? 5 and 9. 3 and 3. 3 and 1. So this becomes 3 times 3 times 5. I'm grouping in 2's. So this becomes 3 square roots of 5. And don't forget to bring down this -1. So this becomes -3 square roots of 5.
We already have the thingies for 20.
Okay, we do already have the things for 20. That was what?
2, 2, and 5.
2, 2, and 5. You will. The more that you do it, the more that you memorize. And then, you know how you guys sit there and you're like, Miss Smith, how do you remember all this? When you do it so many times, it's just like, okay. So 2 times 2 times 5. When I group in 2's, this becomes 2 square roots of 5. And again, don't forget to bring down that negative. So -2 square roots of 5.
So would it be -2 square root of 5 minus 2 square root of 6?
Fantastic, Rebecca. Okay, so Rebecca just noticed I've got +2 square roots of 5 and -2 square roots of 5. Well, that's opposite, so they cancel. Yes, ma'am.
You said that like you did the 2 times like on the outside of 2 square.
Yeah, we took the 2 that we pulled out front and multiplied it by the -1 to get your -2. Yes, because you've got negative square root of 20. And if there's nothing written, that's an unwritten 1. You were looking at the wrong one? Okay. All right. So Rebecca said that this one and this one cancel. So my final answer then should be -2 square roots of 6 minus 3 square roots of 5. Because they cannot go together. Or you could have added it all together. 2 minus 3 is -1. Okay. Minus 2 is -3 square roots of 5. Okay. Let's flip the page. I'm sorry. Do you need me to go back?
Isn't it right above?
Yeah.
Yeah.
You're good? Okay. All right. We've already broken down 18 on one of the previous pages. 3, 3, and 2. So this is 3 times 3 times 2. This is also 3 times 3 times 2. Okay. I'm grouping in 2's. So this becomes 3 square roots of 2. Don't forget to bring down that 2. So 6 square roots of 2. The first one and the last one are going to be the same thing. They both started as 2 square roots of 18. Because they're both positive. So it's like having double of it. They're not opposite. Okay.
So only when they're opposites
that they would cancel out. If that was a -2 square roots of 8, they would have canceled out at the end. Okay.
Wait.
Or -2 square roots of 18. Yeah.
Okay.
Yes. Don't let me confuse you. All right. 12. We need to break down 12. We haven't done that yet. 3 and 4. 2 and 2. 2 and 1. So 2 times 2 times 3. Okay. 2 times 2 times 3. So when I group in 2's, we become 2 square roots of 3. And bring down that -2, so we get -4 square roots of 3. When I combine like terms at the end, my final answer should be? Fantastic. 12 square roots of 2 minus 4 square roots of 3. Thank you, Muhammad. That's my vanilla protein shake and blueberries.
Oh, no.
All right. Last one. Last one in this little booklet. Okay. -3 square roots of 3 minus the square root of 8 minus 3 square roots of 3. 2 of them are already prime. Which ones are prime, Shania? Good. Shania says that this one's prime, so I can bring down -3 square roots of 3. And this one's prime, -3 square roots of 3. 8. We've already broken down 8. 8 becomes 2, 2, and 2. When I group in 2's, this becomes 2 square roots of 2. And don't forget that negative. So we've got -2 square roots of 2. Okay. Rebecca said we're going to combine these first two, and it becomes -6 square roots of 3. And then -2 square roots of 2. Huh?
She should become a mathematician.
I just pick up math.
Yeah, even her sisters and everything, they pick up math really easily.
Right.
All right. Don't lose that. Just set it off to the side for now because we got to glue in everything at one time or else you're going to mess it all up. So we're not going to glue it in yet. Hold on. All right. I need you to look at this page. Okay. Listen, because we need to cut out kind of fast and get started here. So you're cutting out the circle. You're cutting out each one of these individual rectangles. And you're cutting out this as one big rectangle. Do not cut anything else. Cut it out as one big rectangle. That's going to become a pocket in your notebook. So cut everything out individually. Do not cut out the inside square of this. Leave it all as one big piece. Okay? You're cutting out everything. The whole circle goes together. Keep it as a circle. Cut out each one of your individual problems. If you would like the title, you can and glue it in. It's not mandatory. Okay, so there's one piece. You will notice that some of these problems are handwritten in because I thought that the ones that were on this were a little too easy. So I changed some of them.
Oh, thanks.
You're welcome.
Thanks you.
Such a traitor.
No worries.
I had to alter it.
Can't believe you did this.
Well,
Christmas.
Yes.
You're on a naughty list for Christmas.
I'm on the naughty list for Christmas.
Yes.
That's okay.
it's funny to say it doesn't exist. Oh my god.
You're so cool.
Don't say that live on YouTube.
Yeah, I got the word.
What if someone child watches my YouTube
No, my mama tells you, you stop believing, you stop believing.
Yeah, that's what my mom.
I'm like, I believe.
Oh,
First of all,
I was the one that ruined life.
I really think
That's what I plan on doing.
why would you want?
Right.
When I was from 10 years.
Only after you.
You don't even know. Why would you want to
Wait till
You
they.
don't even know.
Wait till
Oh,
they.
He's jolly.
Santa Claus.
That's
right?
creepy.
That's why Santa Claus don't do anyone.
My cousin used to tell me that. I used to believe that.
I woke up this morning to my husband playing I Want a Hippopotamus for Christmas. And I could have killed him.
What is
Like,
that?
I'm all for Christmas
Oh my
music.
God.
But can we please wait until Halloween and Thanksgiving are over?
You don't want to
Thank
talk about
you.
First of all, I'm watching
before
the
Halloween.
Grinch tonight.
You have fun with that.
I am.
I'm watching Hocus Pocus tonight.
Yes!
Lord,
go,
I got
girl.
so excited. That is me and my mother's favorite movie.
Okay,
Rachel.
Rachel is
Our-
I can't wait till my daughter's old enough where that's not like the Sanderson sisters.
Oh my God, yes, The Nightmare Before Christmas.
Yeah.
Oh, that's my
I
favorite.
hate that movie. I hate it.
I'm gonna be the front one.
I watched it so much. I hate it.
My parents were years ago, they took me to my school dressed as a
Right now, it's like, oh my god, like that's all she watches.
Everybody Halloween.
Even when he was in school.
Polar fluorescent.
Yeah, but we do it at night. We only open one at night.
Hey guys, about another minute. We gotta get started on this. Cut, cut, cut.
It's a really old movie.
Yeah.
One of the best ones.
These two really
What did you say? Something really old?
Halloween Town. Watch out.
Listen, I own Halloween Town 2,
Halloween
Halloween
I watched
Town,
it like
and
yesterday.
Return
I was
Halloween
so
Town.
sad when they turned gray. I was like, Halloween Town could not turn gray.
Exactly.
It was like, it just doesn't happen. It doesn't make
That's
sense.
what Riley and I watched this weekend with Halloween Town Marathon.
Me
That's
too.
what the
man is for.
Yeah. I own them all on DVD, so I put them all last week. We had Halloween Town Marathon.
That's what the man is.
You need to watch Halloween Town. You have not been watching. You have not watched Halloween Town.
Listen, I've watched like every single one.
For years.
That's what I
You stay up in the middle of the night. Halloween Town always comes
Really
on
have,
Halloween.
All the movies beyond.
That twin sister relationship, that beyond.
All right,
Go Twitches.
please find your circle that says adding and subtracting. Radical.
I always say that I have crazy is that I'm like Rachel hates that he's that I'm like Rachel does.
Okay. Find your circle that says adding and subtracting radicals. Listen, nothing. Nothing is different. This is reiterating everything we have just done. Okay, nothing has changed. All right, so on this one, it's technically supposed to start here. You can only add or subtract radicals with the same index and radicand. Okay. You can only add radicals or subtract them if they have the same index. So if it's square roots, it can only go with square root. If it's the fourth root, it can only go with fourth root. Okay. And it must have the same radicand, which means everything underneath that square root symbol has to be the same. It doesn't matter whether it's a number or a variable. Okay. So, if we turn this to number 1, group terms with the like radicands. What goes together?
5 square root of 3, 6 square root of 3, and 7.
Okay, so 5 square roots of 3, 6 square roots of 3, -7 square roots of 3. What else? And the other two go together. 4 square roots of 2 and -2 square roots of 2. All I did was highlight what you have the same. Yes, it's going to fold like that. Okay. So we now need to take that and finish it off in number 2. So we're going to turn it. Number 2 says add or subtract the coefficients. So we said that these two go together. So we've got 4 and -2, which gives me 2.
Wait, my bad.
And keep your square root of 2. And then we do the same thing with your square roots of 3. So we've got 5 plus 6. We're at 11 minus 3 or minus 7. 4 square roots of 3.
That's your answer?
That's it. That's your answer. All right. So what you're supposed to do with this one is you need to fold each one of these into the center along those lines. So there's 1, 2, and 3. So when you're finished, you're going to end up with this triangle looking thing. And I'm going to show you how this glues all in so then you can do these problems.
Are these problems homework?
No. These problems are now work.
Are you sure you can?
Okay. So on page 80, we need to put your booklet somewhere. We got to be able to fit this all in. Actually, we can probably do it this way. We can do this at the top, your booklet here. Okay. Now, watch what I do with this one. Okay. Everybody's eyes are up here, so I'm not getting in a little bit. Okay. You are applying glue along this thin edge on the outside, so this becomes a pocket. Okay. So you're going to take your glue stick, and you're only going to put glue here and along the bottom and up this side. Okay, leave that middle part without glue and glue it down. Okay. That way, as you finish these problems, they're going to slide into this pocket.
Wow.
Wow. Look at that.
Mo having difficulty.
Mo's having difficulties.
He don't want to fold.
Okay, so the problems that go along with this, that is now work. Okay, when you are finished with those problems, slide them into the pocket. We'll go over them tomorrow. Your homework for tonight is an adding and subtracting radicals expression made. Woo!
At least you try to make homework a little fun other than just giving.
I tried. I also like these because I also prefer these because they have the answers, so you know immediately that you did something wrong if your answer's not there. Because, I mean, if you go home and you just do these open-ended problems and you do them all wrong, you come in and then I try to rewrite your wrong. At least you know what you did wrong. Huh? It doesn't get folded. You're taking the glue and it's going along the outside edges, that thin band around, and glue it down. That way you've got a pocket. Okay. So when you're finished with this, you can come up and grab yourself a maid. Okay. I will grab one for my friend Cody that's not here.
So what you're basically saying is, we don't finish this right now.